In this lab, we're going to be conducting the reduction of camphor. So camphor has this bicyclic structure, and its reaction with sodium borohydride, which is our reducing agent. The sodium borohydride will react as a reducing agent and give two possible structures. So the mechanism of this reaction, sodium borohydride, sodium plus BH4 minus reacts as a source of hydride ion, H minus. Okay, and the way that happens is it could attack from the top face or it could react from the bottom face to give either of the two products shown. We wind up with BH3 as the byproduct. We can still act as a reducing agent, so this could also deliver hydride as well. So the number of equivalents that we could actually get from this, there's 4 hydrogen atoms to deliver. You should look at your stoichiometry, how many moles of borohydride are we using, and how many equivalents are we actually using in this, if all of them could be delivered as a H minus equivalent. You should think about that. You should also think about which isomer is going to be preferred in this. These methyl groups up top here are very large and they block this face. So we're going to wind up getting very little attack from the top face, and most of the attack is going to be from the bottom face, which is more accessible. Like these groups kind of block that top attack. All right, so the procedure. You're going to be weighing out 0.0132 moles. So you're going to have to convert that to grams. I'm going to let you do the math for that one. And you're going to do that weighing directly into a round bottom flask. You're going to add 8 milliliters of methanol, and we're going to cool that solution down in an ice bath. Get it stirring in an ice bath and cool it down. Then you're going to weigh out 0.016 moles. Again, you're going to have to do the conversion to grams of sodium borohydride. So that should be the first thing you do. You should come into class with these already converted to grams, so you know how much you're going to be weighing out. You're going to add the sodium borohydride. You're going to measure it directly in a vial, and you should keep the lid on the vial. All right, we want to make sure that we're going to keep this away from any potential moisture that could react with the sodium borohydride. So if it's a humid day, we have to worry about the sodium borohydride absorbing moisture directly from the air. It's a reactive intermediate, the sodium borohydride. Then we're going to take it off the ice bath and start adding the camphor solution slowly. Right? We're going to add small portions of our material at a time. So start out with 2 very small scoops, just the tip of the spatula, and let's see what happens, right? The reaction will probably heat up, and that's what we got to keep an eye on. We may have to go back and forth between the ice bath and allowing it to warm up on its own. So these 2 steps right here, I want everybody to pay careful attention to that, right? As you're adding the sodium borohydride, you have to watch what's going on and make sure that you're not adding the sodium borohydride too fast where it could potentially boil right out of the solution. All right. So once all the sodium borohydride has been added, we're going to stir at room temperature for 10 minutes, and then we're going to heat it up to reflux for about 5 minutes. So once we've done that reflux for 5 minutes, we're going to cool it down to room temperature. In an ice bath. And then we're going to pour that reaction mixture into 30 milliliters of ice. All right, so we're going to take our solution from the round bottom flask and pour it directly into a beaker that has about 30 milliliters of ice in it. Right. This is the quench of the reaction. This is the adding of the H plus. The any H minus that's left around, any O minuses that are left around from the camphor reacting are going to be quenched when we add water, and we'll wind up with a hydroxide solution. And it'll be pretty dilute with all this water that we're going to have present there. All right. So once all the ice melts, we should get a solid as our product. Right? And after all the ice melts, you can then collect the solids by filtration. We're going to use the suction filtration, as we've done many times already. And we're going to wash our solids with water. In order to get out your material from the flask, you might have to rinse it a couple times with methanol into it. We want to make sure we get any residual stuff out of our flask and add it to the ice to let those solids form. All right. And at this point, we're going to use parafilm. We're going to cover the flask up. So if you haven't used parafilm, we're going to take maybe a beaker with our solids in it, and we're going to use this stretchable plastic wrap that's going to go over the top of it, and we're going to poke a few holes in it. You can use the tip of pencil to poke a few holes. That'll let any moisture escape. The parafilm's going to keep most of the dust from just getting into the to our containers. You're going to label it with your names, and we'll let it sit for next week. Next week we'll get the weight, we'll get an IR spectrum of our material, and we'll calculate the percent yield, and we are finished with labs after this. After next week, after we get our solids isolated and stuff, well, we're going to start working on our presentation projects, and I'll talk about that hopefully at our class on Wednesday. All right, we'll see you then.